make an area model to show her theoretical probability of making 0, 1, or 2 points in a 1-in-1 situation and a 2-shot situation. By the way, this is a problem that was written off of Brittany Menkes all these years ago. All right. So, in a 1-on-1 situation, we've done this before. So, we have our first shot, our second shot, and her chances of making or hitting her first shot are 1 in 4, or 4 out of 10. So I'm going to draw this line. I'm going to divide my first shot into 2 sections. One which takes up 40% of the grid, because that's the percent of times she makes it, and one that takes up 60% of the grid when she misses. Then, if you miss your first shot in a 1-in-1 situation, you don't get another one. So I'm going to leave this blank. Obviously, this is going to remain 60%. And then if I look over here, I got to take a second shot. And what are my odds of making on my second shot? 4 out of 10. Misses 6 out of 10. So this is where I get 2 points because I hit and I hit. And that is 16% of the time. Over here, we have 1 point because I hit the first shot, missed the second, and I have 24 squares out of 100, so 24%. And luckily, 16% plus 24% equals 40%. And so my probability here is 24% of the time, my probability here is 16% of the time. So let's look at expected value really quick, shall we? So if I get 0 points 60% of the time, that's going to net me 0 points. If I get 1 point 24% of the time out of 100 trips, that's going to give me 24 points. If I get 2 points 16% of the time out of 100, I'm going to end up with 32 points, because 16 times 2 is 32. And so if I add these two together, I get 56 points. Forget that for now. And my box had 100 possibilities. So we divide that by 100 and we get 0.56 points per trip to the line. So that's my expected value for the 1-in-1 situation. For her 2-shot situation, it's a little bit different. We still have our first shot. She still makes it 40% of the time. But in a 2-shot foul, she gets her second shot whether she misses the first or not. So then for our second shot, this division line is going to continue across the whole grid, because if she misses the first, she still gets to take her second. So we again have our 2-point situation here, which remains 16%. But now I have a 1-point area and then another 1-point area, and they are of equal size. So we have 24% of the time on this one, 24% she'll miss and then make. So 24% plus 24% is 48%. And then 0%, miss and miss, 0 points, is going to occur 36% of the time. So when I take a look at my expected value, before I do that, so the big part is this line right here, because if I miss my first shot in a 2-shot situation, I get to take my second shot. So if I get 0 points 36 out of 100 times, that's going to give me a big fat 0. If I make 1 point 48 times, that's going to give me 48 points. If I make 2 points 16% of the time, that's going to be 32 points. So add that together and I get 80 points. 80 points out of my 100 trips to the free throw line is going to give me 0.8 points per trip. I'm running out of room there. So I found my expected value and my probability for getting 0, 1, and 2 points in a free throw shooting situation as a 40% free throw shooter.